This is Mr. G, and this is our warm-up for today's lesson. So pause the video right here, give this problem a shot, come back when you think you have an answer. Run over 3, 2, 1, let's go. We're going to solve the equation x minus 1 times x plus 3 equals 0. Hopefully we remember how to do this. We can just use the zero product property. Since we have two things that are being multiplied and the product, the answer is 0, the only way this is going to make any sense is if one of the things equals 0. So we can put x minus 1 equals 0 and x plus 3 equals 0. Then we just solve. So I add 1, get my first solution is x equals 1, take away 3, and we get x equals negative 3 as our second solution. Now, if you're able to skip some of these steps, that's a good thing. I'm just showing all of my work. All right, let's take a look at our objective now. We're doing chapter 4, sections 5, 6, and 7. That's a lot of sections to be doing in one lesson. Essentially, that means we're putting it all together. We're doing everything, or rather, we're going to use all the strategies from these 3 sections, all in the same types of problems. Anyways, after 3, we should be able to solve equations that contain quadratic expressions. So today we're going to be looking at more complicated equations, but that still contain expressions that we learned how to deal with in chapter 4, sections 5, 6, and 7. Let's take a look at example 1. We've got to solve 4 times x minus 5 times 3x squared plus 2x minus 8 equals 0. All right, this looks like kind of a mess. Now, the first thing I want to ask is this a quadratic? Is this equation going to be a quadratic equation? Now, it's tempting to say yes, because we've got a power of 2 with that x, and we think, oh, that was the big clue. When the biggest power we see is a 2, that means it's a quadratic. But if we distributed here and did x times 3x squared, we would end up with 3x to the third power, making the highest power a power of 3. So this actually is not a quadratic equation, it's a cubic equation, because the highest power we see is a power of 3. But even though this is technically a cubic equation, we can deal with this because it's already written in sort of semi-factored form. It's 3 things being multiplied together. All right, so let's take a look at this. The first thing I want to deal with is this 4 in front. Now, if this were an x or a 4x, I would leave it alone right now. But since it's just a number, I want to get rid of it. And it's 4 times everything, so to undo it, we just divide everything we see by 4. Divide the left and the right by 4 and cancel it out. So then we end up with x minus 5 times 3x squared plus 2x minus 8 equals 0 divided by 4. Well, that's still just 0. Now, at this point, some of us might be stuck because this looks kind of different than anything we've done before, but hopefully, at least part of it looks a little familiar. Because really, this is exactly the same thing we saw in our warm-up. It was 2 things being multiplied together that equal 0. Well, we can split it up then. We're multiplying x minus 5 times that trinomial, and the answer is 0. That means one of those things has to equal 0. Either x minus 5 equals 0, or 3x squared plus 2x minus 8 equals 0. We can split it up using the zero product property. All right, this first equation, we can just add 5. We get x equals 5. So our first answer is x equals 5. This one over here is going to be a little bit more of a headache to deal with. So let's remember our quadratic options here. We can't just get x by itself because we see an x to the power of 1. So we see those unlike terms. So using a square root is out. But we could try and factor or use the quadratic formula. I personally like factoring. I think that's the fastest method. So I'm going to try and factor this. There's no GCF. Always have to look for a GCF first. We see a lead coefficient of 3, which means we need the stupid sentence. Most frogs don't say much. I'm going to scroll down a little bit. 3 times 8 becomes x squared plus 2x minus 24. So our multiplication step is done. Then we have to factor this new trinomial. So this would be, let's see, 2 numbers that multiply to give us negative 24, to combine to give us 2. That's going to be a positive 6 and a negative 4. Then we divide both of those numbers by the original lead coefficient of 3. So that's 6 divided by 3, 4 divided by 3. Simplify the fractions. We get x plus 2. And a little bit more space. Well, x minus 4 over 3, that just stays as it is. Then our last n is moved. So we move the denominators in front. So we just get x plus 2 times 3x minus 4 equals 0. Now, you'll notice this is the first time I wrote equals zero when we were using the stupid sentence because you only want, how do I want to say this? All of this stuff right there did not equal zero because we had changed the trinomial. But after we finish the stupid sentence, then we can put equal zero back. And now we've got another zero product property problem here. We can put x plus 2 equals 0 and 3x minus 4 equals 0. So it's all just the same stuff we've been doing. It just looks more complicated at the start. Take away 2, x equals negative 2. Add 4, a little bit more space. 3x equals 4, divide by 3, and we get x equals, I'm just going to leave it as 4 thirds. So x equals 4 thirds. So we actually got 3 answers here. X equals 4 over 3, x equals negative 2, and what was the other one? X equals 5. Let's rewrite that one down here so they're all together. X equals 5. Those are the 3 solutions we got for this. So when we have equations that are bigger than a quadratic, that have quadratic expressions within them, we can end up with more than 2 solutions sometimes. Let's take a look at example 2. We got to solve x times x plus 5 squared times 10x squared minus 22x equals 0. Okay. Well, this looks a little bit different, but I mean, it's still just a bunch of things being multiplied together that equals 0. So we can split them up with the zero product property. The first thing we're multiplying is that x, so it's x equals 0. Now, remember, in example 1, this was a 4, so we divided it out, but you do not want to divide both sides by x. Don't do that because then you're going to be dividing out one of your factors. You're going to be losing a possible solution if you do that. So if you have a variable in front, just do what I just did and say, okay, so x equals 0. And actually, there's nothing to even solve it. That's our first solution right off the bat. The next thing we're multiplying is an x plus 5, but it's x plus 5 squared. All right, well, we said that equals 0. Let's keep going. And then the 10x squared minus 22x equals 0. Just using the zero product property. All right, well, the first one's done. It's just x equals 0. The second one, x plus 5 squared, so we have to undo that power of 2. We can just take the square root. Take the square root of both sides, so that'll cancel out the power of 2. We get x plus 5 equals, the square root of 0 is 0. Now, normally we put a plus or minus, but we don't need that here because plus or minus 0 doesn't make any sense. It's neither positive or negative. It's just 0. And then we take away 5. Well, 5 so far. That's kind of weird. And we end up with x equals negative 5. That's our second solution. Now we move on to our quadratic part of this. It's 10x squared minus 22x equals 0. That quadratic, well, now this is a quadratic equation because the highest power we see in that single equation is a power of 2. So let's see. We can't just get x by itself because we've got a x to the 1 here. We can't combine like terms. Let's try and factor it. That's always my first step, first attempt at least to try to factor. Look for GCF. I do see a GCF. We can divide both of them by 2x. So let's see what that comes out to. So we write our GCF first. So it's 2x times 5x minus 11 equals 0. And now it's just another zero product property problem. So it's 2x equals 0. Divide both sides by 2. Oh, we get x equals 0 again. So we don't need to write it twice, but it is interesting that it came up twice. So let's keep on going. So then it's 5x minus 11 equals 0. Scroll down a little bit. Add 11. Hopefully we know how to do this part by now. 5x equals 11. Divide by 5. And we get x equals, we could leave it as 11 fifths, or we could leave it as 2 and 1 fifth. That's 2.2, if I'm doing that correctly in my head. And there we go. Let's scroll up so we can see all of our answers. Oh, I guess that is all the answers because x equals 0 was, we had that one twice. So those are our answers. X equals negative 5, x equals 0, and x equals 2.2. Last one for this video. 2x to the third plus 2x squared minus 5x equals 0. Now, right away, this should make you think, okay, this one looks different. This one looks drastically different because we have a power of 3 here. The biggest power is 3. It's not 2. So this is not a quadratic equation. So at this point, we can't use the quadratic formula. We can't try and complete the square. We can't just try and get x by itself and take a square root because those methods only work with a quadratic. But what we can do is try and factor this to create, to sort of rewrite it so that part of it looks like a quadratic. We can look for a GCF. A GCF doesn't need it to be a quadratic. We can still factor a GCF out. Now, if you're just focusing at the coefficients the 2, 2, and negative 5, you might think, well, wait a minute, there is no GCF. But remember, the C in GCF stands for common, and these three terms have x in common. I'm going to divide an x in front, and let's see what happens. We get 2x squared plus 2x minus 5 equals 0. So now we rewrote it so that part of it is a quadratic, or that one factor is a quadratic factor, we can say. Now we can use the zero product property. We just rewrite it. Okay, x equals 0. That's already our first answer. And then 2x squared plus 2x minus 5 equals 0. And now we can solve this quadratic. I always like to try and factor first. There's no GCF remaining, so lead coefficient of 2 means we need the stupid sentence. So most frogs don't say much. Let's see what happens. We multiply 2 times 5, gives us a new trinomial of x squared plus 2x minus 10. Now we got to factor it. Two numbers that multiplied give us negative 10, and add to give us 2. I don't see anything that will work here, because we've got like a 1 times 10. That's not going to give us a 2 if we combine them. The 2 times 5, and that's not going to give us a 2. So yeah, this is not factorable. So, I erased too much. So we just want to erase that. All right, so factoring didn't work, so we're stuck with the quadratic formula. So it's x equals, I'm not going to write out the whole quadratic formula. We should be good at that by now. So let's see, it's negative b, that's negative 2, plus or minus the square root. Now remember, to do this quickly, we want to simplify as we're substituting. So it's b squared, so that would be 2 squared, that's 4, minus 4ac, so that's negative 4 times 2 is negative 8, times negative 5 is plus 40. I'm going to double check myself one more time. So 4ac, it is going to be a positive because negative times that negative right there. 4 times 5 is 22. Yep, comes out to 40. All divided by 2a, that's 2 times 2, that's 4. And let's see, what can we do? Let's rewrite this as negative 2 plus or minus the square root of 44, all divided by 4. We can actually rewrite that square root of 44. Let me do this up here in a different color. So this is sort of like a little thought bubble. We can rewrite the square root of 44 as the square root of 4 times the square root of 11. Since there's a perfect square factor of 44, we can rewrite it as 2 times the square root of 11. We just take the square root of 4 and get 2. So that makes this x equals negative 2 plus or minus 2 times the square root of 11, all divided by 4. Now, we could leave it like that. I prefer to distribute the division and make it negative 2 over 4, which comes out to negative 1/2, plus or minus. Then the 2 divided by 4 becomes 1/2 again. Or actually, we can just write that as the square root of 11 over 2. So in case I just lost anyone, let me show my work here. I feel like I'm being sloppy, skipping steps. So first we distribute. Let me do this in a different color to show you that we're just sort of thinking this. So it's negative 2 divided by 4, plus or minus 2 square root 11, all divided by 4. We just take that 4 and distribute it to both terms in the numerator. Of course, more than I wanted disappeared when I undid that. That's what it is, right? Okay, good. And then we just simplify. So the negative 2 over 4 becomes that negative 1/2. And the 2 and the 4, that becomes a 1/2. So technically there's like a 1 in front of there, but we don't need it. We can just write it as the square root of 11 over 2. So that's our two exact answers. If you wanted to type that into a calculator, you could and get two decimal approximations. Let me see what that would be. Let me grab a calculator real quick. So negative 1 over 2 plus the second square root of 11 divided by 2 comes out to 1.16 rounds to. And then if we subtract it, negative 1/2 minus the square root of 11 divided by 2 comes out to negative 2.16. So those are our two decimal approximations. So it's x equals 0, and x is approximately 1.16 and negative 2.16. But I prefer to have it as a exact answer. All right, that's it for today's lesson. Hopefully this all makes sense. As always, if you have questions, let me know. Enjoy the rest of your day.